Chapter 7, Section 4 is about polynomials. At the start of this chapter, we went over what makes something a monomial, which were those singular terms that we were looking at, and we were multiplying them and dividing them and kind of looking at some of the properties that they have when you're doing that. Well, now we're going to start taking those things that we talked about with monomials and apply them to these bigger equations, bigger functions that are going to be called polynomials. So I want to go over what makes something a polynomial, what are the different ways that, like maybe you've already seen them, or ways that we've talked about them, and what are some new things that we can do with polynomials in this section. So first of all, a polynomial would be a monomial, so like all those things that we've talked about already, or it could be the sum of monomials. So if you start extending them or making them bigger. So for example, remember monomials were anything that was like a number, like 4, or a letter, like x, or the product of those, so like 4x, or you could even have like 5y, or we could have things that are a little bit more complicated, like we could say 4x plus 5y, or I could say 3x minus 7. I could even start getting into something a lot bigger, like x to the 4th plus 3x to the 3rd minus 2x squared plus 6x minus 10. That would also be considered a polynomial. And you can see how all I'm doing there is taking these smaller terms, these monomials, and I'm combining them by putting plus signs and minus signs in between the individual terms. So all of your terms are separated by an addition or a subtraction sign. We still have some rules though that we need to follow and just make sure that they're not happening. So for example, you cannot divide by a variable, so you can't have something that looks like this. You can't have like 5 over x or like 3 over y. You see something like that, that's going to automatically not be considered a polynomial. We also need to have positive whole number exponents. So we can't have like x to the negative 2 power. You also can't have like any roots, because if you have a square root, like square root of x, that is the same thing if they rewrote it as x to the 1/2 power. We can't have that happen. Same could be said if instead of a square root we had like a cubed root. The cubed root of something would be written as 1/3 for the exponent. So if you see anything like that, kind of those maybe weird looking situations, that's going to automatically be not a polynomial, not what we're looking to deal with right now. Now, when we have these polynomials, we can classify them by the number of terms that they have. So, like I was talking earlier, we've already seen monomials a lot this chapter. Those are those individual terms that make up these really big equations. Then we have what's called a binomial. That would be if you had 2 terms. So, like coming back up to this big list of examples I had, these first 4 examples, those would all be considered monomials because they each were made up of just one single term. The 4x plus 5y, the 3x minus 7, I went too far. The 4x plus 5y and the 3x minus 7, those each have 2 terms. So those would be called binomials. Now, I don't have an example up here of a trinomial because this next example I have has way more than 3 terms to it. It's got 5. But so a trinomial would just have 3 terms. So x plus 2y minus 5. That would be an example of a trinomial. Now we're going to start talking also about the degree of these polynomials, and sometimes we'll have to look at the degree of the individual monomials that make it up. Sometimes we'll have to look at just one of the terms at the start of the problem to figure out like what the degree of the polynomial would be. So degree of a monomial would be the added up value of your exponents. So sometimes your monomials will have just a single term, while other times you'll have maybe 2 or 3 or 4 terms that you're looking at for the monomial. If that's the case, then you're going to have to add up the exponents that all of those little letters have. For a polynomial, so if you're looking at like a really big thing, that's going to be the highest degree on one of your monomials that you see. And we'll start doing some examples later and you'll kind of see how that works. Another thing that we'll talk about later is descending order. That's kind of the order or like the specific way we want these to be written. where we want to start with the biggest exponent and then gradually work our way down to get down to the smallest exponents. And then we'll also talk about the leading coefficient. Now, we've talked about coefficients before, where you have those numbers that sit in front of your letters. And so when we talk about the leading coefficient, we're talking about the very first term in your polynomial, what number is sitting in front of that letter. And it could be a 1, it could be a 2, could be a negative number, could be really anything that they would want to put in front. What we're going to practice first is just going over how do we classify these polynomials. So by looking at the examples, I want us to be able to say, yes, it's a polynomial, or no, it's not. And if it's not, I want us to be able to say why. If it is a polynomial, I want to kind of start getting into that idea of we can look for certain things, start classifying it with more specific information to give the polynomial a little bit more detail, so that if I was trying to maybe solve it or graph it in the far future, nothing that you'll be doing right now, I'd be able to by kind of looking at some of that key information we're talking about. So for this first one, I automatically see the first term has that square root. And we talked about that up above, that this would not be a polynomial. So I'm going to say no. And the reason is because that square root of x technically means that it's x to the 1/2 power. That's not a whole number exponent. That's a fraction. So that's why it can't be considered a polynomial. Again, if you look at the next one, I see right away that I've got x raised to a -2. So again, that's a problem because we can't have negative exponents. So I'm going to say no, and I'm going to write negative exponent. Now, this next one here, I don't see either of these two situations that I saw up above happening, like no square roots, no negative exponents. Looks like everything's okay. There are 3 individual terms here that are just separated by a plus or minus sign. So I'm going to go ahead and say that, yes, this is a polynomial. Okay? And so because I'm saying it's a polynomial, I should be able to start classifying some of these things a little bit more in detail. For example, they call it a trinomial because this thing has 3 terms. The first term is that 4x squared y. The second term is the 2y. And the third term is this negative 3x. So that's why they're calling it a trinomial. Now, the leading coefficient and degree, these kind of have to go together. Let's talk about the degree first. The degree is when you look at your letters and you look at their exponents. And if you have multiple letters, you have to add their exponents together. Okay? So I'm going to use D to represent degree here. And for this first one, I have a 2 on the x. Remember that y technically has a 1. So I'm going to have to add 2 plus 1. So my degree is going to be 3 for that first term. Then if I look at my degrees on my next 2 terms, they each only have 1 letter. And they're both standing alone. So that means they have exponents of 1. And so this degree for the second term would be a 1. And this degree for this one would be also a 1. To figure out what the degree of the whole polynomial is, remember we said up above, is that it's the degree of the highest monomial. So the highest monomial was this 3 here. So that's why they're saying that the degree is 3. Okay? Now, the leading coefficient then has to come from the term that has the highest degree. So because that highest degree is 3, the leading coefficient has to be that 4 that's sitting in front. And that's where that came from. The leading coefficient has to come from the term with the highest degree. In this example, it just so happened that the very first term had the highest degree. So that 4 was already sitting in front of it. But there's going to be cases where it's not in the correct order. They maybe have the term with the highest degree farther down in the problem. And so that's why I said look at the degrees first, because if I needed to rearrange it, put it in that descending order, I would want that term with the highest degree to come at the very start, and then I would gradually work my way down through the rest of those degrees, going down in order, descending order, so going like from the highest number, counting down one at a time. And so I would want to make sure that I have that biggest degree sitting in the front. So don't just assume that the first term you see in your problem is going to be the term that your leading coefficient and degree come from. There's going to be times that they switch that around because they're going to want to check and see if you're paying attention. Okay, so watch out for things like that. What I want you guys to do right now is practice this. So go ahead and pause the video here, take a minute, and write down your answers for these two practice problems. Yes or no. If it's a no, say what's causing the issue. If it's a yes, try to classify it like we were doing up on that example. So for this first one, I should have said no because of this y right here. That has a negative exponent. For the second one, you should have been able to say yes, it is a polynomial. Okay, if we start to classify it a little bit more in detail, we've got two terms here. So I would have called this a binomial. Then I want to look at the degree and the leading coefficient. So to find your degree, you should have looked at the letters on your terms and their exponents. So the first one just has an x to the 5th power, so the degree would be 5. For the second term, your degree should have been the x and the y together, which they both just have 1s, so the degree should have been 2. So the biggest degree I see is a 5, so that should have been the degree for the whole polynomial, which then means also that your leading coefficient should come from that term, which is that 2 that sits in the front. For these next couple of examples, we are going to do the exact same thing that we were doing up above. It's just that now we're going to kind of really break it down into like a table to kind of keep our thoughts a little bit more organized. Okay, when you start doing examples on your homework, I'm not going to provide the table here for you. You could always create your own table, but sometimes the problems aren't going to ask for all of this information. They might just want to know, like, what's the degree of the polynomial, or what's the leading coefficient, or how many terms does it have. They may not want to know all of this information, but as we start going through these examples together here in class, I want to go through all of that information for all of them so that you just get more practice under your belt, so that you feel better about looking at these polynomials and knowing, how do I classify them? What's the names I should be giving? How do I find this information? So that when you have to do them in smaller chunks, it's just a lot more manageable and you know exactly what they're asking you to find and you don't have to do all of this work, okay? So when we write these examples out to get started here, I'm just going to grab each of the terms that I see and drop them down here into my boxes. So for this first one, I'm going to put x squared y in the first box, 2y in the middle one. And when I write the next one out, be really careful because this does have a minus sign here. So I almost need to think of that as being a negative in front of that 3. So I need to also bring the negative sign with it. Just get in that habit. If you see a minus sign in the problem, that it needs to go with the term that follows it, kind of like it's a negative. Now, the degree of the terms, that's when you look at the exponents. So remember, for this first one, we've got 2 letters, so we have to look at both of the exponents. X has a 2, y has a 1, so 2 plus the 1 means we have a degree of 3. For the next one, the 2y, that has just a y with a degree of 1, and the last one does the same thing. It's only got a z, so the degree is 1. Now, after you get the degree of the terms written out, we don't need to fill in the rest of the boxes here, so I'm just going to scribble those off, because the next piece of information comes from those 3 numbers that we just wrote down. The 3, the 1, the 1. The degree of the polynomial, that's the biggest degree that you saw. So we saw 3 for that first one, so that would be the degree of the polynomial. That means that you have to look at that term, which should hopefully be the first one in our table, and you look for the leading coefficient now, which would be whatever number sits in front of this x squared. Now remember, anytime that there's nothing written here, there's technically a 1, so the leading coefficient would be that 1. So now we look at what type of polynomial do we have. Well, I've got 3 terms here, so the name of that would be trinomial. Okay, so after you get kind of your degree of term written down, the rest of this information you only need to fill in on the first column. You don't need to do that for the rest, because these 3 answers right here, this goes for the polynomial, that whole poly that we're looking at. I don't care so much about the individual terms anymore, because now I'm just generalizing, like, what type of polynomial do I have, what's its degree, and then what's its leading coefficient. Because those are the things that, like I said, in the far future, like when you guys in a couple of years go to Algebra 2, you're going to spend a lot more time talking about these polynomials, talking about what their graphs look like, how you would find their solutions, okay? That's when this information becomes really important for us to be able to find to make those problems easier. What I want you guys to do right now is practice this. So do the exact same thing for this problem that I just did up above. How I started this is I put in my terms, so x to the 5th, then xy, 3z, and then my 5. My degree of my terms, this first one is just 5. This next one had 2 letters, both with exponents of 1s, so my degree should have been 2. The degree of this next one is just a 1. And hopefully this last one didn't trick you. There is no letter, which means that the degree would technically be 0, because there's no letter, which means there's no exponent on that letter. Okay, then again, I don't need to fill in any of those columns. Looking at these numbers here, 5, 2, 1, 0, 5 is the biggest, so that would be my degree of my polynomial. My leading coefficient then comes from that very first term, because that has the highest degree. Again, there's no number written there, so it means that there's a 1 for the leading coefficient. Now, this one had 4 terms to it, and we talked up above on the previous page that if you have more than 3 terms, we stopped giving them special names and we just call them polynomials. Or you could say poly for short if you wanted to. Okay, so we're going to continue to do what we've been doing, but we're going to expand on it a little bit more. Now, this first table, this kind of just goes over again some of that information that we've already been through. Like, how do you classify a polynomial by the number of terms that it has? Okay, none of this is new. We've talked about this already. We know what a monomial is, binomial, trinomial, and polynomial. I'm just providing some more examples for you guys to kind of see what they might look like. Now, as we get into these next couple of examples, they're going to stop mixing letters together. So you're only going to see one single letter, like only X's or only Y's. Most of the time you're going to see X's just because that tends to be what we use the most in math. What we're going to do for these next couple of problems is we're going to still continue to fill out the chart, okay? And we're still going to find the degree and the leading coefficient and all that stuff. But we're also going to now be able to name these polynomials 2 different ways. One is by the number of terms that they have. So you've already been doing that. Monomial, binomial, trinomial, or a polynomial. But we're also then going to start classifying it by their degree, okay? So when I look at this big table here, it might seem a little overwhelming, but what we're looking for really is in this last kind of column here, these 5 have specific names for your polynomials when you're classifying them by their degree. Okay, so maybe put a big star here for you guys so that later on when you have to do this on your own, you have like a good spot to just like you see the star or highlight it or whatever so that you know like I need to come here for the second name. Okay. All right, so we're going to fill in some of these empty spaces and kind of talk our way through this chart. So this very first row, we're missing the name and the number of terms. The example they give me is just a 5. I just have a single term here, which means that we're still dealing with a monomial. So I would call this a monomial even though it's just a number. Remember, numbers can be monomials. That means that there's only one term. Now, it's just a number, 5, doesn't have a letter. Okay, so that means that its degree, we saw this in that above example, is 0 because there's no letter. We would consider this to be a constant. Okay, what a constant looks like is a straight line. This would be like if I had y equals 5. Y equals 7, y equals negative 5, y equals negative 7. They would be flat horizontal lines that go through those y values on the graph. Okay. Now the next example I have, they're still calling it a monomial because we only have one term, 3x, but they've added the letter now. So this changes the degree up to a 1 because remember this x has an exponent of 1. This now becomes linear. Now, linear looks like constant, except it doesn't have to be flat. Okay? Linear means that it has a slope. This slope would be 3. And so it's going to cause the graph to change its direction. It's going to have a specific rise over run, unlike the constant does. The constant has no slope because it's flat. So a linear line, remember, those can go up or those can go down. We saw a lot of those types of lines in Chapter 6, in Chapter 5, and in Chapter 4. We've been dealing with graphing lines, so you should know how to do that. Okay? Now, the next one we have here, they're calling it a binomial because we have two terms, and they're writing 2x squared minus 5. So the x squared is where our degree comes from, because the degree always comes from the letters. So 2 is the degree, and the new name for this one is quadratic. The quadratic graph looks like a U shape, and it can point up or it can point down. In a couple of chapters in this class, when we get to chapter 9, we'll spend a lot more time talking about the quadratic because there's so much we can do with the quadratic form. You'll also spend, again, I'm kind of going again to the future, you'll spend a ton of time talking about the quadratic in Algebra 2. I know when I teach my Algebra 2 classes, we spend like a good month and a half just on the quadratic because, like I said, there's just so much we can do with it. So you'll see a lot more of the quadratic in the future. So just kind of maybe store that in your brain somewhere because it's going to come back. The next example I have here in my chart, they're calling this one a trinomial because it has 3 terms. We've got 5x squared, there's term 1, 3x squared, that's term 2, and then minus 2x, that's term 3. So your degree, it comes off of that letter with the biggest exponent, which is that x to the third, that very first one. And so your degree is 3. The new name for that is cubic. And the cubic graph looks like this. Kind of like a snaky shape, like an S. It could also go the other way. Okay, and depending on which way it goes, that all is based off of the leading coefficient. So that number that sits in the very front, like what is it going to cause the graph to do? Then the next example I have here is called a polynomial because, again, polynomials refer to anything that has more than 3 terms. So anything that has 4, 5, 6, 7, 8, 9 plus terms. So this one's got 5 terms here. That very first one has x to the 4th. 4 is the degree, and this would be called a quartic graph. Okay, I like to think to remember this name like there's 4 quarters in a dollar. So quarters kind of sounds like quartic to me, so I'm able to kind of associate 4 quarters. 4 means quartic for the graph. What the quartic graph looks like, kind of like a W shape. Again, it can also go the other direction. Okay, for this next one, we got to fill in some stuff here. They want us, for this next example, to create a binomial. So a binomial, if you need to look back up above, that means it has 2 terms to it. Okay? They are saying, though, that the degree has to be 5, and the name for that one is quintic. Okay? So 5 means that the very first term needs to have like x to the 5th power. So you could write just x to the 5th if you wanted to. You could also do something a little bit more fancy like 2x to the 5th, or you could do like negative 2x to the 5th if you really wanted to go crazy with it. Then you need a second term. Now the second term could be anything you want. It can be another number, it could be another number and a letter. The only thing you have to make sure of is that you don't give it an exponent that is a 5 or bigger. You need to have an exponent that is smaller than 5. So you could have like an x to the 4th, an x to the 3rd, an x squared, or just an x, or you could have just a number. Doesn't matter, but you just cannot have x to the 5th, because I need to have 2 different terms for this binomial. So you could just do like minus 4, or you could say minus 4x to the 3rd. You could add on something if you wanted to be a little bit more fancy with it. But really, that's a great example of a binomial, 2 terms, that has that leading degree of 5. It's quintic. Okay? Now, what does the quintic graph look like? It's pretty similar to the quartic. It just has one more turn so that your arrows end up going in opposite directions. Okay? For this last one here, we've got a trinomial, which means we need to have 3 terms. They're specifying that the degree needs to be 4, so the word for that would be quartic. And again, you need to start with an x to the 4th power. So let's just start with 2x to the 4th power. And now we need 2 more terms. And what I like to do is just kind of gradually work my way down. So next one I'm going to put is minus 7x squared. And I'm going to say plus 5. There's lots of examples that you could give for that. Yours does not have to look like mine. It doesn't have to match exactly. You could have said x to the 4th plus x to the 3rd minus x squared if you wanted to keep it just real simple. If you want to get a little bit more creative and start putting in numbers in front, plus and minus signs, like all those things, you can do that. You have kind of that ability to create these. But you do just want to make sure that the other exponents that you're having don't match the first one, okay? And don't get bigger than the first one. They always want to be going down. I would also just advise you too that if you're writing out like bigger polynomials, you try to already start putting them in order. So like I wouldn't want to put the 5 before the 7x squared because that wouldn't be considered in descending order. You want to start with the term with the highest degree and then gradually work your way down one at a time with those exponents until you have no more letters. So any like plain numbers that you have, those should always go at the very end. Okay, so what we're going to do now to kind of wrap up this section, we're going to do a couple more examples where we do what we were doing with those tables up above. Like we're going to list out the terms, find the degree of the terms, and then start naming like what's the degree of the polynomial, what's the leading coefficient. But then we're also going to start really focusing on, is it in order? Is it in descending order? And then what are the proper names? So not only are we calling it a polynomial or a monomial, are we calling it a quartic? Are we calling it a quadratic? Are we calling it a linear? Like what are we giving its name so that we can be a little bit more specific about what type of polynomial we're working with? Okay, so I want to show you how to do this. And then I'm going to give you some time to practice, all right? When I look at these examples, the very first thing that I'm going to try to make sure I do when I'm putting them in my table is to go ahead and put them in that descending order. Like I said, they're not always going to give it to you in order, and the reason why they do that is because they want to make sure that you're paying attention. So when I look at my terms here, when I look at all of these up here, I want to just do a quick scan and find the term that has the letter with the biggest exponent, because that needs to go first. So the mistake that I see a lot of students do is they just assume it's the first one. But if you look, the second one actually has an x to the 4th. That's going to be the very first term that should be in my table, okay? And it does have a minus sign in front. So when I write it in here, I need to make sure I do like negative 5x to the 4th power, okay? I like to cross them off when I'm done. That way I don't forget any or I don't actually write the same one down 2 times, okay? Then I look and I see, okay, that first one does have x to the 3rd, which is bigger than the other two. So I am going to put 7x to the 3rd second. And then 3x would go next. And then your 9 would go last. Okay, so what you did there is you already put it in descending order. So if you look down here, they have that descending order that matches what we put up there. They're just putting back the plus and minus signs in between the terms. Okay, so that is something that you'll just want to start right off the bat with. Put it in order because it's going to make writing it back out in descending order so much easier and faster for you. Okay, now let's talk about the degree of the terms. So you look at those exponents. Now, like I said, these examples are only going to have one letter, so we don't really have to worry about adding up our exponents on this one. We're just going to look at the letter and what's the exponent that it has. So this first one says x to the 4th power, so its degree would be 4. Next one would be 3. 3x would be 1. 9 would be 0 because it doesn't have a letter. Again, we don't need to fill in any of this. Looking at those degrees of the terms, the biggest one is 4, which is, again, why I put it first, because I want that biggest degree to come first, so that I can just kind of isolate all of my thinking to this first column. So my degree of my polynomial is going to be that 4. Your leading coefficient is going to be that number sitting in front, which is a negative 5 for this one. And then we talk about its type. There's 4 terms, so we would call that a polynomial. And then we need to look at its degree. Okay, so the degree of the poly is where you want to look. That's 4. So coming back up to that chart, remember how I said to star this or highlight it? Looking here, degree 4 is quartic. So that's where they're getting that second name from. That's why they're writing quartic down here, is because it has a degree of 4. So not only are we going to call it the polynomial, like we already did, but now we're going to give it a second classification based off of its degree, which is going to be now called quartic. Okay? So, now it's your chance to practice. There are 2 practice problems that follow this one. Here's the first one, and here's the second one. I'm going to give you guys some time to try to do these. So I would like you to pause the video right now if you're watching it, and I would like to you to try to do these on your own, and then come back and watch them and see if you did them right. So the first thing I did on this one is I wrote it down in descending order, and I did have to put that x to the third first. Then the 5x squared came next, and then the negative 7. I didn't actually have to use this last row, so you may not fill in the whole chart just because they may not have all the terms that you need to do that, okay? The degree of the terms, this first one's a 3, and then a 2, then a 0. Then we don't need to fill in anything there. The degree of the whole polynomial should have just been 3. Leading coefficient should have been a 1. And we should have named this a trinomial, because there were 3 terms. The descending order would have been that x to the third plus 5x squared minus 7. That's what you wrote across the top there. Your classification, I would have called this a trinomial. And then looking at its degree, the degree of the poly here, it's 3, so that name would be cubic. All right, for that second practice problem, I would have put the negative 3x to the third first, and then the 7x second. Don't need to fill in anything here. I also won't need to fill in anything here. The degree of my terms were 3 and 1. Degree of the polynomial should have been 3. Leading coefficient should have been negative 3. This has 2 terms, so I would have called it a binomial. Descending order would have been negative 3x to the third plus 7x, and I would have called this a binomial. And then degree of the poly is the other name that we need, which is still a 3, just like the last practice problem, so you should have also called this cubic. A mistake that I see happen a lot here is that students will want to write binomial and then they'll want to write quadratic, because they think two terms, and they automatically look at 2 on the degree chart. Remember, the degree comes from that exponent. So it's not always just 2 terms, 2 is the degree. 3 terms, 3 is the degree, okay? Because it's not going to match up like that all the time. So make sure that if you made that mistake, that you recognize that you did that, and that was probably your thinking. And I need you to remind yourself that that's not how this is going to work, so that you don't continue to do things like that in the future.